Hi everyone, in this video we're going to do the palindrome numbers lead code here, and let's dive into the problem. We are given an integer x. We have to return true if x is a palindrome and false otherwise. So a palindrome is just basically something that reads the same forwards and backwards. So from left to right, right to left, it's still the same. So you have 1 to 1 here will be true, and something that's negative will be false, and this 10 here will be false as well. So let's take a look at a basic approach. What we can do simply is we can take the input and we can create and we can convert it to a string. So number equal x dot toString. And then we're going to initialize two variables. One L is 0, and we're going to have another variable which equals to the number length minus 1. And then we're going to have a while loop. We're going to loop through this number string here with L is less than R. And then we're going to increment L, and we're going to decrement R. So basically what we're doing is we have like 2 pointers at the edge of this number string, and then we're going to go slowly towards the center. And while we're doing that, we're going to check if the left side does not equal the right side. So if it does not equal the left and right sides does not equal each other, then we know it's not a palindrome. So we can just say return false. And if we just go through the while loop without returning any values, then we know that this string is actually a palindrome. So we can then return true. Okay, so we have a simple solution here. Let's just run the test case. And as you can see, all the test case passed. Let's just submit it. Okay, so as you can see here, we actually got an accepted solution here. So this is how we do this problem with the most simplest solution. But there's another more complex solution that's probably more efficient. So instead of, so basically what we want to do is we don't want to convert this this number into a string, and we're going to do some manipulation so that we can check if it's a palindrome. So let's go back to the description, and I'm just going to remove this code here. And what I'm going to do is I'm just going to write some pseudocode first. So let's say we have an input of let's say 1331. And what we can do is we can actually use some arithmetic operations to actually revert this number. So how do we do that? First, we get the last digit here, which is 1. So what we want to do is we want to say remainder equal the input. Let's just call it x. X is 131. So x modulus 10, which will actually equal 1. And then we want to assign this answer to the something called reverted number. So we're going to initialize this reverted number into 0. And then what we're going to do is we're going to say reverted number equals remainder. Okay, so once we do that, we can now modify this x input, this input number here, by removing that remainder. So now reverted number, no, not reverted number. We're going to x equal x minus the remainder, and then we're going to divide x by 10. So essentially what we're doing here is we're taking this number 1331, we're subtracting the remainder, so this becomes 1330, and then we will divide it by 10, so it becomes 133. So now basically you have extracted the last digit out from the input. So now you have x equals 133, and you have 133, and you have that reverted number as 1. Okay, so now we have to loop this. So basically what we're going to do is we're going to loop it as long as the input while x is greater than this reverted number. And the reason being is wait, I'm going to just do the calculations first. So while x is greater than reverted number, and then you will have another remainder calculated. Now x is 133. So now x is, let's just change that, 133, and reverted number is 1. And then now this x modulus 10 will become 3. And then now you can't really change the reverted number into remainder. You can't just assign remainder to the reverted number because you want it to be 13. You don't want it to be 3. So how you do it is basically you take reverted number and then you multiply it by 10. And this will work for any length of digit. So basically every time you add a number to a digit to this reverted number, you multiply by 10. And reverted number times 10 plus the remainder. So this one will become 13. And then x equal x minus remainder, which will equal 10. No, it equal 130, and then you divide it by 10, it should equal to 13. And then we have x equal 13 and reverted number equal 13. So now we've reverted this last two digits, and then we can actually check if this is equal to this, then we know that it is a palindrome. So let's just code up this solution here. While x is greater than reverted number, let's just copy this. I don't think this is even pseudocode. Okay, let remainder x modulus 10, right? Reverted number will reverted number be this. Initialize this, let reverted number x minus remainder, that x divided by 10. You can actually do this. And remove this last line. And then, well, okay. So now we've done this manipulation, we can just return x equal reverted number. So if it's equal, then it's true. If it's not, then it's false. So anyway, but there is an issue with this while loop here. If we have, for example, a input that has odd digit numbers. So I'm going to just show you what's going to happen if x equals 131. Right, it's still a palindrome, but it has odd numbers. Let's start with 0. And then we'll have x10 becomes 1. This one will become 1. And then minus 1, this is 130. And then this will be 13. And then we will have x equal 13 and reverted number equal 1, and then it will go back into the loop again. Remain x becomes 13, remainder is 3, and then we're gonna assign this to that. Becomes 10, this one becomes 1, so we will end up with a final value of x equal 1 and the reverted number will be 13. So obviously we know that the original x was 131, but if we run through this code here, x equals reverted number is actually going to return false. So what we can do is here we can say if x equals reverted number, we're going to return true. And if it still doesn't return true, then we can actually do some manipulation. We can take the reverted number and we can just remove the last digit. So basically we can do what we did here with the reverted number. Say let's just call it reverted number. We're going to subtract the modulus, and then we're going to divide it by 10, and then we're going to return the same thing here afterwards. So that bracket, return x equals reverted number, and then that takes care of the odd digit numbers. So because we're actually removing the last digit, because the middle digit actually doesn't matter in a palindrome. So it can be any number as long as the left and right sides are the same, it's a palindrome. So we've actually taken care of that case. So we're still not done yet. We have another 2 more issues. We know that negative numbers are not palindrome, and this loop actually doesn't take care of it. So we have an edge case here. We can say if x is less than 0, then we can return false. Or if it is 10, you see this is an issue if it is 10, for example, or anything that's divisible by 10, we actually will have a problem if it goes through this while loop, because every time we do a modulus 10, it becomes 0, and then reverted number will always be 0, and this will cause an infinite loop here. So we can actually take care of that edge case as well. We can say or x is greater than 0 and x modulus 10 equals 0. So that takes care of the edge cases. Let me just remove the pseudocode here. And that is the solution without actually converting this x into a string. And then let's just run these test cases here. Let's see if it's passed. Okay, all test cases passed. Let's submit it. Okay, so basically it's accepted, and we've actually had a better space complexity. As you can see now, the space complexity, because it doesn't convert x to string, the space complexity becomes O of 1. It's a constant space complexity. And in terms of time complexity, it's actually log 10 of n, because we're actually, every time this loop goes once, we're actually dividing it by 10. So it can be a large integer number here, but it doesn't exactly go O of n, it's O log of n. So we've come to the end of this video. I hope you enjoyed it, and we're going to be doing more of these Leetcode problems here, and I'll see you in the next video.